Good morning, Geometry Honors students. So this is Mr. Chen again, so welcome back. And this one today we would like to talk about the lesson of the properties of parallelogram. Okay, so now let's look at that for this one right here. Let's go back to the polygon first. So yesterday we forgot to talk about the convex, concave polygon. So anytime they see the convex polygon, so that means once you connect that the vertex to another vertex, you see that the diagonal, it's within the polygon. Okay, so convex polygon, so that means once you connect from one vertex to another vertex, so the diagonal, they're always being founded inside the polygon. If that's a concave polygon, so that means once you connect the vertices, so one of the diagonal, it could be outside the polygon, like this one right here. If you try to connect that from this point to this point, so the diagonal can be founded outside the polygon. So this one, regular polygons, it's equilateral and it's equiangular. Equilateral, that means all sides are equal. Equiangular, that means all angles are congruent. Okay? So if you see that the irregular polygon, so convex, again, diagonals must be founded right in between, right inside the polygon. And then the concave polygon, so that means the diagonal could be founded outside the polygon. So yesterday we talked about all this kind of definitions, formula, the way to find the diagonal, the way to find out the measure of the exterior angle, and also the way to find the sum of all the interior angle. Okay, so now this one is some kind of practice you guys can work on. I just scroll it down, so it's pretty similar to the one that we've been doing. So you guys are more than welcome to try this. So the main goal for the lesson today, we just want to get into the special properties of a parallelogram. Okay, so all those properties. Okay, so right here. So any polygon with four sides is called a quadrilateral. However, some quadrilateral have some special properties. We'll get to that in the later chapter. So these special quadrilaterals are given with their own name. A quadrilateral with two pair of parallel sides, it's a parallelogram. So as you can see that here, the parallelogram. So parallelogram ABCD. So it's one of the properties that the opposite side, they're always parallel, like segment AB, segment CD. And also BC and AD, they're considered parallel as well. If you see like a double vertical line, that's a symbol for parallel. So properties of parallelogram. Okay, so the first one is showing that opposite sides are congruent. So like this one here, what are those opposite sides? So this one is saying that QR is congruent to segment PS, and also that QP is congruent to RS. So the other one, if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, opposite angles. So for this one, like angle Q is congruent to angle S, and also angle R is congruent to angle P. Okay? And the third property, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive angles, so that means we're talking about like angle Q, angle P. Combine them together, it's always 180. And also for the other one here as well, angle S, combine it with angle R, it's 180. And also the consecutive angles right next to each other, so angle Q plus angle R, it's also 180. And also angle P combined it with angle S, it's also considered 180. If a quadrilateral is a parallelogram, then its diagonal bisect each other. So that diagonal, so that means you want to connect it from one vertex to another vertex. So for QS, so this one is congruent to PR. Okay, so that means you can say that while bisecting each other. So instead of just saying that diagonal, they're congruent, so you can just say that this one here. So let's say that there's a point in between, there's a point of intersections of those two diagonals. So let's say this one is point G. So that means QG is congruent to SG. and then PG is congruent to RG, just like that. So for the following exercise, so 14 to 16, each quadrilateral is a parallelogram. Find the indicated value. So A, so what is just what, 12, and then B, 7. Again, opposite sides of a parallelogram, they're always congruent. X, which is what, 112. Y, so 180 minus 112. Okay, so showing the work. Then that would be 68. Consecutive interior, it's always considered supplementary. And then the rest of that is quite similar. So measure of A, bisecting. So if this one is 10, the other one got to be 10 as well. So B, so this one is 10, so the other one is 10. X, alternate interior angle, so 62, this one got to be 62 as well, degrees. And then Y, vertical angle or opposite angle, so what is that, 33 degrees, just like that. And then the rest of this is just more practice, you know. Okay, so now let's see what else that we have. So level B problem, so now we just raise up the rigorous bar. So according to the diagram here, so this one, it's a parallelogram. So ABCD, so sine AD, so segment AD, it's extended through D to E. And DB, it's diagonal. If angle EDC, the measure of angle EDC is 65 degrees. Okay, so this angle here is 65 degree. And then the measure of angle CBD, it's 85, so they're all given. So find the measure of angle CDB. So angle CDB, which is this one right here. So in order to get the measure of that angle, so one thing that I need to notice, so this one is a parallelogram. Okay, so if this one is a parallelogram, that means this two angle got to be considered the congruent angle. Okay, because this one is considered like an angle bisector. Okay, well, kind of like an angle bisector, but you know, so this one we don't want to make assumption yet. So now, in order to find the measure of this angle, so let's see what we can do. So one thing that we notice, if this one is 65 degree, so that means this angle down here on the bottom will be 65 degree as well. If this one is 85 degree, that means this angle is also 85 degree. Okay, so in order to get this angle, so this one is considered like a linear pair, or once you combine all three of these angles together, it's considered 180. So 180 minus the sum of 85 and 65. So 180 minus, so 85 plus 65, which is what, 150. Subtract, so it's what, 30 degree. So again, if you try to make this one as an angle bisector, so the assumption would be considered incorrect. So again, using that, all the prior knowledge, alternate interior angle, so using that DB as a transversal, so we get that 85 degree. And then this one is just considered either supplementary or linear pair, subtract from 180. So that would be the measure of angle CDB. Okay, so the other one, so here's another one that you can just find out. So in the parallelogram, draw the parallelogram. So L, M, and O, an exterior angle at vertex O. Exterior angle at vertex O is 72 degree. Okay, so vertex angle, extend it. So the measure of that is 72 degree. Well, this one, it would be up 2. This one would be up 2. So once you extend it, so 72 will be this angle here. Find a measure in degree of L. Degree of L. So if this one is 72, well, this angle here got to be 72 as well. Consecutive interior angle. So that means subtract from 180. So we get 108 degree for measure of angle L. Okay, so now let's do the one with the proof. So given that diagram ABCD, it's a parallelogram. Okay, so ABCD, it's a parallelogram. So another thing that we notice, if that's a parallelogram, that means the opposite line segment's got to be what? Parallel. And also they got to be what? Congruent as well. So using the properties of parallelogram. Okay, so the diagonal. Another thing that we notice, so angle GHA, so GHA is congruent to angle FEC, FEC. Okay. Another thing that we notice, segment HB. So segment HB is congruent to segment DE. Okay. So that's what we know so far. And now you want to prove that GH. Okay, so this GH is congruent to EF. So in order to show that GH is congruent to EF, so one thing that we need to show here is that triangle AGH must be congruent to triangle CFE. Okay, and the reason why that is because we want to apply that one of the theorem, CPCTC. Okay, so once we get to that, and then we can state that the corresponding segments of the congruent triangles must be congruent. So start out with the given. So I'm not going to rewrite this one is all given, you can just put them all together. Okay, so one thing that we notice in order to prove this two triangles congruent, so we do already know that EC, okay, let's see. We do know that DE is congruent to HB, okay? And also that parallelogram, the opposite line segment, got to be congruent. So for the next statement, you probably want to say that segment EC, so that equals segment DC minus segment DE. Okay, so this will be considered segment subtraction postulate. Okay, so segment subtraction postulate. And then the other one, similar, for step 3. So down the bottom here, so AB, or just say that HH is, well, so it's equal to AB minus HB. Okay, so it's the same reason. So segment subtraction postulate. And then after that, you can say that segment EC is congruent to segment AH. So this one is by using the segment congruence. Okay, because those two segments are exactly the same. These two segments are exactly the same. Once you subtract, you end up with the exact same quantity. So once we prove that those two line segments, they're congruent, another thing that we can state, the angle. So angle CAB is congruent to angle DCA. Okay, so those two angles right here. And the reason for that is because the properties of the parallelogram. Okay, so property of a parallelogram. So once we get that, the psi, the angle. So here's another thing that you want to stay here. So the angle GHA. Okay, so angle GHA. So angle GHA, it's congruent to angle FEC, so we put in that earlier for the given statement. So therefore this one can be proved by using angle psi angle. So therefore triangle AGH is congruent to triangle CFE. So this one by using angle psi angle. So once we get into that side angle, proving the triangle congruence, so we can state the final statement. GH is congruent to EF by using CP, what about step 8? So this one is just optional, depending on the given statement, the way you state that. Some people prefer to, put in the given statement separately, but I prefer to put them all together with one statement. Okay, so that's one of those proved. So here's another one that you guys can try. Okay, so again, PQRS, so it's a parallelogram, so that means we can apply the special properties of a parallelogram. So the opposite angle, they're always congruent. Okay, always congruent. And then line segments, opposite line segments are parallel, and also they're congruent. Okay. So another thing that we notice, YQ. Okay, so YQ, so that bisects angle PQR. Okay, so PQR. If that's considered the angle bisector, so one thing that we notice, so that means this angle. Okay, so PQR. So that means this angle right here got to be congruent. And also XS bisects angle PSR. So that means this two angle got to be congruent as well, by using the definition of angle bisector. So again, so state that all the given element. So PQRS is a parallelogram, YQ bisects angle PQR, XS bisects angle PSR, just put it right here. So that's why I put in ditto. So for the one that you're doing, make sure that you need to rewrite this one for that step 1. So in order to prove that SY is congruent to XQ, okay, so one thing that we need to show here is that we want to prove that SY QX, it's a parallelogram. Okay, because that if this one's a parallelogram, so that means the opposite side got to be congruent. So in order to do that, and let's see, one thing that we can do, so there are two ways you can do it. So we can prove that these two triangles, they're congruent. Okay, so these two triangles, they're congruent. Another thing that we can do, we can draw the auxiliary line right here, but let's just prove those two triangles congruent here. So since we do know that PQRS is a parallelogram, so if this one's being the angle bisector, okay, so let's say that angle S is congruent to angle Q. So by using the properties of a parallelogram. And we do know that angle S, let's put it this way, angle PSX is congruent to angle RSX. Okay, so definition of angle bisector. And also the other one here as well. So angle RQY is congruent to angle YQX. Again, by the definition of angle bisector, so this one did them. So once we show that those two angles, they're bisecting, well, they're congruent to each other, so that means the opposite angle got to be congruent. So that means angle PSX is congruent to angle RQY. And this one is by using definition of congruent angle. So we just showed that those two angles, they're congruent to each other. Another thing that we can state, so SP is congruent to RQ. It's also using the properties of the parallelogram. So basically right now what we got here is that those two angles, they're congruent. The line segments, they're congruent. And let's see what else that we can show here. Okay, so we got angle, psi. Okay, angle, psi, angle. So angle P is congruent to angle R. It's also the properties of a parallelogram. And therefore that means the triangle can be proved by using angle, psi, angle postulate. Okay, so the congruent triangle. So triangle SPX is congruent to triangle QRY. So by using angle, psi, angle. And for number 9, you want to state that PX is congruent to YR or RY, CPCTC. And then finally, since we proved that those two line segments, they're congruent, so we can just using that the segment subtraction postulate to prove that SY is congruent to XQ. Okay, so let me just set up another step here. So finally, so subtracting that, okay, SR minus YR, which is the same as SY. So segment subtraction postulate. And also within the same statement, you can state that PQ minus PX which is the same as QX. So this one is all about the segment subtractions postulate. And finally, step 11, just state that SY is congruent to segment QS by using the congruent segment, definition of congruent segment. Okay, so it is a long proof, so got to be very careful. So once we prove the triangle congruent, there's so many things we can find out. The corresponding line segments must be congruent. And also using that and then segment subtraction postulate, we can get that SY is congruent to XQ. There's no need to prove this one at SY QX. It's a parallelogram. I mean, we can do that, but that would be tedious, and that's going to be more work. Okay, so the one that we talk about today, so the properties of the parallelogram. So making sure that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angle are supplementary, diagonal always bisect each other. Okay, so here's the exit ticket problem, so things that you guys can do. Okay, so any questions that you have, so please put into that YouTube channel, okay, for the comment bar. Okay, I'll see you next time.